Welcome everyone. Thank you for joining us for today's webinar. My name is Iftikhar Ahmed and I'm technical head at Pioneer Wireless Services Private Limited. Pioneer is a leading provider of service and training on different projects in telecom. Pioneer give a multiple opportunity for the fresher to build up their career in telecom field. We have the different domains like how the telecom engineers are work. So we're gonna train the candidate into the SOW basis. We have the many candidate resources which has been working in India as well as in overseas with the different projects. I'll just show you the list where the candidate has been got recently. Our resources are working on it, like they are working on Ericsson, Nokia, Samsung, and there are the different objects. Like they are working as a post-processing engineer. Some of the engineers are working as a drive test engineer as well. We have some as working as RNO engineers for the different projects on Ericsson. They are the candidates are working on roll with the Samsung project as well. This is the overseas projects, like some of the resources are working for the Kuwait part for the this is a swap project in the Kuwait, and we have the projects in UAE. The candidate are working on at the Salat, and they are working as a drive test engineer, RNO engineers, post processing engineers. We have O&M engineers. We have the different resources which can support as a BSc engineer, or like we have the NOC engineers, where the company will give the opportunity for the candidate to get build up their career in that. So this is about the Pioneer Wireless Services. So today we are presenting about basic GSM drive test steps, which can make a candidate clear idea about what exactly the drive test and what we have to do in the drive test and what are the important parameters we need to observe in the drive test. If you have any questions during the presentations, please type them into the question box in your go-to webinar control panel, and I will break up the presentations, and we'll also have a time for the questions at the end. All right, so let's get begin start. Like when we work on like as a drive test engineer on certain projects, so what we have, like we have the different type of the softwares. Like I want to show you about, I want to say you about like what exactly the softwares are been used while you're doing the drive test. Drive test, when you do it, actually what is mean by the drive test is nothing but taking the exactly picture of the network, doing the analyzing part on checking where what is the signal strength of a certain cell, like what is the call drop, what are the like interference issues, or it can be like any swap will be there in the sectors. So there are the different type of activities we need to do it on it. While you're working, the drive test can be done for the different like different activities, as I said you, like an SCFT, single site function test drive, like we have the SSV, we have the cluster migration, like we have the benchmarking, we have the opti drives. So there are the different procedures are there for the different drives. So today I'm just going to show you this basic idea about how to start your work, like what are the softwares parameters are there, like what are the important parameter we need to observe while doing the drive. So today I'm going to show you about the basic steps about the GSM drive test, like you can work same way like in the WCDM and LT. So there are the different parameters we need to observe, depends on the technologies which you're working on it. So it get begins, like this is the temps investigations, it's 10.0.5 the version, like they have the different versions like 13.2, like 14.2, like we have 15, 16, even currently it's working with the 18 version as well. So just we need a basic idea like how to operate the software. So this is the webinar is depends on like how to be get handle the softwares and what are the observations we have to do in doing the drive test. So we have like different sheets, as you can see in this. We have overview, we have the signaling, we have data, we have map, scanner, and there are the certain type of settings like we comes under the control and configuration. Let us come in overview. So when we go for the 2G drive, we need to open the certain parameters and certain windows. There are the more important windows are there what we need to observe on it. We're going to discuss on it. So you can see here like we have the presentations. We can go to the presentation. We're working for the GSM, so go to the GSM and select the parameters. So what are the more important windows we have it? We have current channel. We need to focus on the current channel. We have presentation, GSM, we have radio parameter, like the same you can adjust the windows manually or automatically. We have an option to set the windows, like presentation, We have the serving plus neighbors, which shows the information about what is my present cell and what are my neighbor cells are there. Or if you want to select like in one shot, like we have the view and navigator. If you go, like we have the presentation over here, we can click on GSM. Here we have interference. Here we can click on C by I. C by I is nothing but the co-channel interference, the interference which we are getting by the same carrier frequencies. So it has a certain ranges. We need to check about that basis on the radius of the coverage of the cell, like how it's overshooting, what is a strong cell is shooting in certain area. So the basis on that we can create the interference, and we need to resolve the issues about by doing the physical optimizations or assigning the power or checking the different parameters on it. Now we have other part like CA. This is C by A is nothing but carrier adjacent carrier interference, adjacent channel interference also we can say it. Now we required the events here and the part. So when we require the events, we have signaling. You can click on the signaling and you can click on event. This is your events where you can see all the part, like where the call drop happens, where the handover is happening, when you initiate a call, like how much time it took to initiate a call, like many things, like whatever the events are there, it will be getting ping on that window, so we get clear idea about it. So now the second part is very important, like we need to insert about the site data, we need to insert about the vectors. It is a regional database, usually we'll get it when we work on it, as either we are working for AP or Telangana, or it can be for the working for Bangalore, Pune, Mumbai. So depending upon that, the database will be get allocated to the engineers. So we have an option map. You can go to the map here. Now in the map you can see the windows, and here we can see the positioning map. So you can click on it. Once you click on it, here you can get the different information. So what I'm gonna do it, I just click on MIP. This is a site database, MCOM site database. I can see it. I can open this. Now the second part, what I need the roads, I need the vectors. So I click on the vectors. So here I can get the vector information as well. So this is my complete like Andhra Pradesh database where we have it. So this is the roads where you have like plantations, you have the agriculture's land, like different clutters. I can say the clutter types are there. So basis on this clutter type where the vectors can be designed on it. So this usually in a tab file we get it, the vectors. This are nothing but we have the sites over here. You can see this is are my sites. Now if I need to label the sites, we have an option here, the layer control. You can click on the layer control, and you always try keep this site database below the coverage layer. So here you have the options to go in the labels, and you can edit the labels, you can increase the size of the labels and do it. Okay, so we get the clear sites which have been serving by a mobile station in certain area. So what I'm gonna do it, I just play the log file over here. I can go to the open button. Now I'm just playing a one log file. This is already recorded file. Now in this file, like when I play, like you can see there are the different values we are getting, there are the different numbers we are getting. What is this, how it's coming, like what exactly it means by. So I'm going to explain you about that. So we have the current channel, we have the GSM radio parameter, we have the serving plus neighbors, we have C by I, we have the C by A. So these are the important parameters, these are the important windows which we need to focus on it. So let's begin with the current channel first. So in the current channel you can see, like we have the time, we have cell name, we have CGI, we have band, we have different options over here, right? So what is this time? Time is nothing but the system time. System time is nothing but when we started the drive, whatever the Windows time has set, that is we call as a system time. When we have cell name is nothing but we need to get the cell name, means we need to load the cell file. From where we can load the cell file, we have an option in the configuration general. In general we have the cell file loaded, you can click on it, you can add and you can select the cell file. But right now I'm not having the cell file, so I will explain you about the cell file part in other sessions. Like even we have the session on how to create a cell file by using a text database or Excel database. Usually it's there in the format .cel. So I'll show you that part also in my other sessions. Now we have the other options we call as a CGI. What is a CGI? CGI is nothing but we call as a cell global identity, which is consists of a mobile country code, mobile network code, location area code, and cell identity. What is this mobile country code? Mobile country code and mobile network codes are nothing but we call as a network identifier. Network identifier, so where every operators have their unique identifier numbers, that is we call as a MCC and MNC. You can see 405 and 25 here. The for a certain operator have their country code and network code. So here what I'm gonna explain you about this part, like MCC and MNC are nothing but this is a network identifier we get through the IMSI number. What is this IMSI number? IMSI number is nothing but the international mobile subscriber identity number, which shows the identity of each subscriber in the GSM network. So this IMSI number has the starting 6 or sometimes we get the 5 numbers, which is consists of MCC and MNC. 405 and 25 are nothing but the mobile country code and mobile network code we are getting through the IMSI number, and the rest of the number which are used for identifying each subscriber in the network. Now if I come to the LAC, LAC is nothing but the location area code. Location area code, you can see like 17161 is usually a group of cells which are planned in a certain geographical area. We given with the one location area code, that is we call as 17161. Usually it can be one BSC, one location area code, or it can be more than that. But always the planner engineer will plan in making sense in that, like the cells should be not more in a one location area code, or it should not be less in a one area code. Why? Because like if it is a more, we get the more paging request rate and it is increase the load. If it is a less cell, we get the continuously a location update request where it can get let you know to the SG drop. Then we have the CI. What is the CI? CI is nothing but the cell identity, where it is consists of like 5 numbers here, 20461. So the 2046 is the BDS where the mobile is serving, and the one is showing the sector. Like sector are nothing but the antennas which can be served. So I'll show you here. Like you can see the mobile is serving 2046. In this, like we are serving the first sector, we have second and third. Obviously when we go around these cells, we have a different handovers or cell reselections where we can changes the cell over here. So this is about the CGI, cell global identity. Now we have the cell GPRS support. The particular cell which is serving by the mobile, it is compatible for the GPRS node. It shows yes or no. Then we have the band is 1800. It depends on where the operator got license on it. Either they got license on 900 band, either they got a license on 1800 band. Depending upon that, we get the frequency bands on it. So there are the certain bands are there where the GSM can be get design on it. Now we have the BCCH ARFCN, that is we call as a broadcast absolute radio frequency channel number. Broadcasting frequency is 671. This is a serving frequency we have it. Then we have the TCH ARFCN. TCH ARFCN usually is showing empty because we are not in the call, we are there in the ideal mode. Ideal mode means we connected with the network, but we are not doing any activity. We are not they're on call or not sending a message, or you're not using any data services. You just connected with the network. That is we call as the ITL mode. We have the BSIC code. BSIC code is base station identity code, where it has 2 numbers, as you can see, 1 and 6. 1 is NCC and the 6 is BCC. We call as the network color code and the base station color code. This BSIC code is usually used to get identify a cell for the base stations, because this code are used to get identify the cell, because the same frequency can be served by a different base stations. So to get identify that, we have the BSIC code. Then we have the mode is in ideal, because you're not doing any activity here, you just connected with the network. So obviously when the mobile is there in the ideal mode, it's always get the signaling with the help of BCCH channel. What is this BCCH? Is a broadcast control channel which give the signaling when the mobile is there in the ideal mode. If you come to the radio parameter, here we have RX level. RX level is nothing but the signal strength which receive from base station to the mobile stations. It has certain ranges. RX level has a range of 0 to minus 120 dBm. Within 70 we call is the best, within 80 we call is a good, within 90 we call is average, above 90 it's bad, and above 100 is worst. So So we have the different RX level ranges here, and here we can see it like we have like different information about it. We have the serving cell like 671, as you can see here we are serving frequency as a 671, and we have the BSIC is 616, so you can see the 16, and the rest of are nothing but the neighbors like surrounding cell. So whenever the mobile is there in the ideal mode, when the mobile is there in the ideal mode, this all information will get with the help of the BCCH channel, we get with the help of the broadcast control channel here. Now when I initiate a call, let me like get play on it. Like when we are playing a log file, we can go with the further steps about the dedicated mode. I'm going to show you like what are the important parameters we can get in the dedicated mode when the mobile initiated. Now here you can see we have established the call. Now when you establish the call, here we are there in the dedicated mode. Now we got the time slot. What is this time slot? Time slot is nothing but like we have one TRX. TRX is nothing but we call as a transmission and receiving unit. One TRX is nothing but one TDMA frame, time division multiple axis. On this one TDMA frame we have the 0 to 7 time slot. There are totally 8 time slot, and each time slot has the time of 0.577 millisecond. So each user get the time of transmitting the speech of 0.577 millisecond, and to complete one TDMA frame it takes 4.615 millisecond in the GSM. So our call is going in the time slot number 0. That means we are there in the TCH TRX. They are the, again we have the two type of the TRX. One is the BCCS TRX and another TCS TRX. So I'm going to explain you other sessions about the TRX and elaborate about that part. Now we have the channel type TCH. Now we have the traffic channel also in the different type. We have the traffic channel in the full rate and traffic channel half rate and enhanced full rate channel also. So which carry the speech in different speech rates are there. If you're there in the full rate, you will get carry the speech as 13 kilobits per second. If you're there in half rate, 6.5 kilobits, and data rate also gets changed. When you transmit the data, it takes in the half is 4.8 kilobits per second. In the full, it transmit the data is 9.6 kilobits per second. And plus ACGS channels are nothing but the association control channels. The traffic channel is associated with the two more channels, that is we call as the fast association control channel and the slow association control channel. We have the speech full rate. This is the channel type. We are using here the speed codec as a AMR adaptive multi-rate with the half rate. If the TCH is half, then the AMR also we have the half rate, and which is protect the database when you are sending on it. We have the ciphering algorithm. What is the ciphering algorithm? Ciphering algorithms are nothing but the security which can be get executed when you're making a call. There are the different security has to be done. Like there are the algorithms we'll use A3 and A8 algorithm in the GSM. So network will generate some random number by using the KI, that is a parameter which are there in the network and SIM card, and that random number are been getting sent to the mobile stations. So mobile stations calculate and generate another number we call as a series number. So there is a comparison in your database. Sub channel number is showing the position of your SGCH channel, like how many SGCH channel has been utilized when you're making a call. We have hopping channel yes. Sometimes we'll get hopping channel no as well. When we get the no, when our call is going in a BCCS TRX. When your call is going in a BCCS TRX, we'll get the hopping channel no. Why? Because we are not taking the hopping part in the BCCS TRX. Hopping will only happen in the TCS TRX. So hopping channel yes will get in the TCS TRX. We get the multiple hopping frequencies which are been getting broadcast, which are been getting hop on it. Now we have a mobile allocation index offset. This is the part like which can pick the best list to get hop and also make some time separations between the hopping frequencies. HSN we call as a hopping sequence number. There is a one HSN for one side. There is a one MIO for one TRX when it is getting hop. So this is about our current channel. If I come to the radio parameters, in the radio parameter we have the RX level and RX. You can see in the RX level we have RX level full and sub. What is RX level? Full and sub. When you're there in the dedicated mode, you're applying the DT expansion. DT expansion is nothing but we call it a discontinuous transmission method. Actually this method are used to save the battery power of the mobile station. Whenever we transmit the signal, your DTX the transmitter gets on. When there's no signal are been getting, when there is no voice signal is there, the transmitter gets off. So basis on that we are measuring the RX level sub. So usually we consider when you're there in the dedicated mode, we will consider as a RX level sub. RX quality. What is RX quality? RX quality is nothing but like we call as a sound quality, the amount of sound quality we are receiving on it. Like it depends on the bit error rate and the frame error rate, how the percentage of error we are getting in the bit error rate, the percentage of quality goes bad. RX quality usually have the ranges 0 to 7, but we can see here 0.14. So it's not showing in the it's not showing in the dB, it's showing in the percentage. If you want to change the settings, like we have the settings that we can change into the dB, you can right click, you can go to the properties. When you go to the property, you have the cell contain. In this we have the header is the element full rate or half rate. Then we have the first row is for the RX level, and the second row which is there for the RX quality. If I'll click on RX quality, when I click on the second row, we get the RX quality. You can see RX quality is showing in the percentage. I can change this. I can change this to the dB here. So RX level full, I can apply. Okay. Then I click on sub. Again, I'll change the sub, RX level sub, and apply. Okay. So as I said, okay, then it comes showing the value in dB. It's like RX quality has a ranges 0 to 7. So when it is get increased, it is getting bad, getting the interference on it. As I said, you the bit error rate, the percentage of error we are getting in the bits. Usually it has ranges 0 to 26%. So basis on the bit error rate calculations, where your quality get degrade here. SQIMOS we call as a speech quality index mean opinion square, where it has ranges like 1 to 5 usually. So maximum will consider as the best. C by I is nothing but the co-channel interference, where we are getting the interference by the same carrier frequency. It has the default ranges -5 to 35, and always consider above 15 is good. But here we have some threshold value for the C by I. With the hopping, we should be considered as a minimum 9 dB, and without hopping should be the 12 dB. We need to be considered as a threshold value. We have the MS power control level. The power level should be get maintained by the base station order to the mobile station to transmit the power. As I said you about the DTX. DTX is nothing but discontinuous transmission, which are used to like make it the transmitter on when the voice signal is present. If there is no voice signal, the transmitter goes off. But it's work on voice activity detection. So we call as we have some comfort noise in that. There are the different techniques which you use in the DTX part. So in further sessions I'm going to explain you about that part as well. We have the timing advance. Timing advance are nothing but the time it takes to transmit the signal from the mobile to the base station. The delay, like access by the signal passes from the mobile to the base station, that is we call as a timing advance. During a call, like the BSE or BTS network continuously calculate the timing advance and send it the mobile, because from one base station there are the several users are connected and they are in the several distance. So what time to send the frame, it has been getting to know by sending the timing advance value. The RL time out counter. This is a very important parameters in the case of maintaining the radio link between the mobile station and base station. So they have to be sent certain like timer here. It is the operator defined timing. We can say it like it is a depends on optimizations what RL time they have been paid and they kept on that. It has a pinging, like whenever the subscriber, whenever the users are getting more interference or it is out of coverage area, so suddenly it started pinging when the satch frames are missing. So they start counting in the reverse order 36, 35, 34, 30 till 0. Before getting 0, if we come back to the coverage area or if we remove the interference in certain area, so your call will get continue, or else you will get the call drop there. MS behavior modified are nothing but like it is kind of settings where we have it. We can log the frequencies, so it will get set some numbers over there like C alphabets. We have like to log, we get C or B, or so different behavior of your mobile station is going to show in the MS behavior modified. As you can see here, like what are the hopping frequencies we have it and what are their interference we are getting on. So C by A values we can get it, so we are not getting any interference here. We have a good range of coverage and the range of quality here. We are getting 0% bit error rate here. Now here you can see like we have the BSIC, the base station identity code 13, which is a serving cell, and the frequency number is 674. So you can see 674 frequency and the BSIC is 13, and this is the signal strength. So it's showing the sub actually. So you can see 79 here, 79, and those are the neighbor frequencies are they. But here some of the BSIC is not been we are not getting any BSIC. We are getting till 26. So measurement report has been considered which are been correlated with the BSIC. So this where it every 480 milliseconds it sends the measurement report to the BSC, where the BSC can take the decisions about the handover, where the measurement reports will go with the help of you can see in the signaling part. This is the signaling part where we have it. If I'll click on this measurement reports, so only like 1, 2, 3 and 4 BSIC codes are there. So measurement reports are going for this only 4 BSICs. You can see here, if I click here, as I said you about for we have the 66, 22, 25, 26 and 15. These are the BSIC codes. So we have the BSIC codes here, 66, like we have 22, like we have 13 and 26. So these are the BSIC which are been sending to the BSC. So BTS and BSC it will get transmitted. It consists all the reports. So in the signaling we get layer 3 and layer 2. They are the many things. We have the different SIP messages which we need to analyze. We need to see the system information type 6, information type 4, 1. So they are the different reports. We can see different kind of protocols are used: radio resource protocol, mobility management protocol, call control protocol. These are the protocols which can be used. We have the different type of the channels, like we have the synchronization channel, we have broadcasting channel, we have the SAT, FAT, which is work on it. So these are the channel information, frequency channel informations will get through these channels. So these are the layer 2 and layer 3 signaling which we need to be analyzed, and we need to be have a good hold in the drive, so we can get fine about what is the layer 3 and we can understand better about that. And this is the map, this is the route. What is this route? This route is about the coverage. This is we call it the coverage layer. So usually we have the settings over here. So in this settings you can get the coverage layer. So you're getting here the coverage layer. If you need the RX quality, also we have the option. So you can edit here, you can select the different RX quality. This is the part where we are getting it. If you want RX quality, you can select from here the RX quality plot also. This is the RX. If I want to take the RX quality, I can select the RX quality. Okay, I can make some offset here. So when I click on this window, I get the I'm just uncheck here about the C by I and FER error here. So when I click on it, so here you can see it, we got the two layers. One is for the coverage, other is for the quality. So we have a different settings. So basis on it, like we have the different like scripts we can make on the command sequence. We have the different equipment settings. We can get the equipment configurations. We have the different audio indicators which you can make activate or deactivate the sound basis on it. So this is about the basic, a very basic idea about like the GSM part. So we have the other sessions also, like then we have the different modules where we give the training. The entire training has been designed in the part of the candidate to get start their career. Like we have the different modules where we can take the candidate from basic level to the higher level. We train the candidate on planning part while using different tools. We're going to show you the different tools in post processing, like Actives. We have the Temps Discovery, we have the GenX Assistance. So they are the different companies, they are the different equipments where we're gonna train you on it. So I'll end with the sessions here, and thank you everyone, and it was a pleasure being with you. I will see you next time. Have a good day.